thermochemistry nude sums start panikalam. Let us do the sum from the following data. From the following data. Calculate the enthalpy change for the combustion. Calculate the enthalpy change for the combustion of cyclopropane at 298 Kelvin. The enthalpy of formation of CO2. The enthalpy of formation of CO2 gas, H2O liquid, and propane gas, and propane, and it is not propane, it is given propene gas are minus 393.5 minus 285.8 and 20.42 kilojoule per mole respectively. The enthalpy of isomerization of the enthalpy of isomerization of cyclopropane to propene is minus 33 kilojoule per mole. Let us write the required equations. Let us write the given equations. We will write. Okay, first one is what is the equation? Means enthalpy of combustion of cyclopropane. So cyclopropane, what is the formula that we will see? Cyclopropane in the sense 3 carbon atoms we have to write in a cyclic manner, and for each carbon atom we have to give 2 hydrogens. 2 hydrogen atoms we have to give. It is cyclopropane, we can say. It is undergoing combustion, therefore it is combining with the oxygen gas to give what? In the sense carbon combining with oxygen to give what? In the sense carbon dioxide gas. Hydrogen with oxygen, what means? Water liquid. Okay, now we have to balance the equation by keeping cyclopropane as 1 mole. So 3 carbon atoms, thus 3 carbon dioxide, 6 hydrogen atoms, therefore 3 H2O. 3 into 2 6, here 3 9, insert that 9 by 2 oxygen. For this delta CH is equal to how much? In the sense this we have to find it. Calculate this end, so we have to find this one. So delta CH we have to find. Okay, so what is other given data? In the sense enthalpy of formation of CO2. So CO2 how to write? In the sense graphite solid plus O2 gas gives carbon dioxide gas. For this delta H is equal to minus 393.5 kilojoule per mole given. Next, enthalpy of formation of H2O liquid. H2O liquid how to write? Means hydrogen gas plus of O2 gas gives H2O liquid. For this delta H is equal to minus 285.8 kilojoule per mole. Then enthalpy of formation of propene. Propene formula is CH3 single bond CH double bond CH2 propene gas. For this constituent elements is 3 carbon atoms in gases graphite solid. Hydrogen is here 3 1 4, here 2 6, therefore 3 H2 gas. For this enthalpy of formation given, that is 20.42 kilojoule per mole. Next given enthalpy of isomerization of cyclopropane into propene. Cyclopropane formula is this one. This triangle symbol is called cyclopropane. It is converting into propene. It is called isomerization. This because molecular formula is same, structures are different, therefore isomerization. For this, delta H is equal to minus 33 kilojoule per mole. Okay. So cyclopropane is converting into propene. Cyclopropane is converting into propene. Okay. This is called isomerization. Why? Because molecular formula same, structures are different. For this, delta H is given. Okay. So now given data, you see that number 1 equation, number 2 equation, number 3, number 4 equations are given. Using this, we have to find this one. First one, we have to find it. Sorry. How to find? In the first one, left side cyclopropane is there. Now we want cyclopropane in the left side. Therefore, equation 4 we will write. We will take as it is. So equation 4 we are taking as it is. Equation 4 says that cyclopropane gives propene. Cyclopropane gives propene. So for this, what is a delta H? Delta H is given minus 33 kilojoule. Okay. So this we have written. Next, what we want? Next, we want carbon dioxide 3 times in the right side. So carbon dioxide available in the first equation. So multiply first equation by 3. So first equation we have to multiply by 3. Okay. So first equation we are multiplying by 3. Therefore, 3 times carbon in graphite, 3 times O2 gas gives 3 times CO2 gas. For this, delta H is how much in the sense minus 393.5 kilojoule for 1 mole of graphite. For 3 moles in the sense we have to multiply by 3. Sorry. Then we want 3 times water. Water is available in the equation 2. So equation 2 we have to multiply by 3. Equation 2 we have to multiply by 3. Sorry. So equation 2 we are multiplying by 3. Therefore, we are getting 3 times H2 gas, 3 by 2 O2 gas, 3 by 2 O2 gas gives 3 times H2O liquid. 3 times H2O liquid. Here delta H is how much in the sense? Minus 285.8 minus 285.8 into 3 kilojoule. Okay. This for water we have given. Next, what we want means we want cyclopropane. We don't want propene. So we have to cancel this propene. This propene is right side is there. So is there any equation in that propene left side is there means take this left side propene and right side propene will cancel with each other. So see that anything given or not, you see here given equation number 3c propene is there. Reverse this propene, reverse equation number 3, propene will comes to left side, propene will comes to left side, then we can cancel easily, therefore equation this 3 let us reverse, equation 3 let us reverse equation 3. So what you will get in the sense propene we will get in the left side, we will get propene we will get in the left side, right side what we will get in the sense 3 times graphite we will get 3 times graphite, then 3 times H2, 3 times H2 gas we will get, then delta H is how much in the sense this plus 20 becomes minus 20.42 kilojoule, minus 20.42 kilojoule we can say. Okay. So we have reversed. Let us add all the equations. We will see whether we are getting required equation or not. We will see. Okay. Now what are getting cancelled? We will see 3 times graphite is getting cancelled. 3 O2, 3 by 2 O2 means 4.5 O2. 4.5 O2 is there. Sorry, okay. And then this propene cancels. Now this cyclopropane will take left side. In the right side, what is there means O2 is there. How many times means 9 by 2 O2 is there. And 3 carbon dioxide right side, 3 H2O right side. Okay. So is it a required equation? You see, yes, it is the required equation. Required equation we got. For this required equation, we want delta H. Let us add all the delta H values. All these delta H values, let us add. We will get a required delta H. So required delta H is minus 2091.32 kilojoule. Okay, this is a required delta H value. Okay, so we got the required answer. We got it. Next sum we will take. Next sum we are taking delta H for combustion of ethane and ethane. Delta H for combustion of ethane and ethane. Ethane means acetylene or minus 341.1 or minus 341.1 and minus 310 kilocalories and minus 310 kilocalories respectively. Okay. Which is better gas welder and why? which is a better gas welder, which is better gas welder, and why, which is better gas welder and why. Okay, so here what is given in the sense, ethane is given. For ethane, combustion given, enthalpy of combustion given. For ethane, enthalpy of combustion is given. It is acetylene. For acetylene also enthalpy of combustion is given. For acetylene also enthalpy of combustion is given. Which is better fuel, they are asking. Now ethane and acetylene is having different molecular formula. Therefore different molecular mass will be there. When molecular mass is different, we cannot compare which is better fuel directly by taking enthalpy of combustion. Enthalpy of combustion is for 1 mole, is for 1 mole. 1 mole means molecular mass. Molecular mass for these two is different, so let us make them weight is same, then we will see. Okay, so first we will take ethane. First we will take ethane. Enthalpy of combustion of ethane we'll see. That means 1 mole of ethane, 1 mole of ethane on combustion, 1 mole of ethane on combustion releases how much amount of heat? In the sense 341.1 kilocalorie of heat is liberated. Okay, so 1 mole of ethane is liberating this much amount of heat. 1 mole of ethane means what is a mass? 1 mole of ethane means what is a mass? Means carbon atomic mass 12, so 2 times means 24, hydrogen is 6, therefore 30. So 30 grams. So 30 grams of ethane on combustion releases 341.1 kilocalorie of heat. 30 gram of ethane. Therefore 1 gram of ethane will liberate how much? 1 gram of ethane will liberate how much? 1 gram of ethane on combustion, 1 gram of ethane on combustion liberates how much amount of heat? 1 gram of ethane on combustion liberates how much amount of heat? That means 341.1 kilocalorie by 30. Okay, it is 1 gram of ethane liberating this much amount of heat. So 1 gram of ethane liberates 11.37 kilocalorie of heat. Okay, so 1 gram of ethane liberating this much amount of heat. So now we will see for ethane. We will see ethane. We will see. Okay, so 1 mole of ethane. 1 mole of ethane. Okay, 1 mole of ethane means what is the mass? Carbon 24, hydrogen 2, therefore 26 gram. Okay, so 1 mole of ethane. 1 mole of ethane on combustion. 1 mole of ethane on combustion liberates how much amount of heat? In the sense 310 kilocalories of heat. 310 kilocalories of heat. Okay, 1 mole of ethane, 1 mole of acetylene. That means 26 gram of acetylene. 26 gram of acetylene on combustion releases 310 kilocalories of heat. Therefore 1 gram of acetylene. Therefore 1 gram of acetylene on combustion releases how much amount of heat? That is 310 by 26. 310 by 26. So how much we are getting? In the sense 11.92 kilocalories of heat. 11.92 kilocalories of heat we can say. So now see, it is 1 gram of acetylene. It is 1 gram of acetylene. Acetylene only called ethane, C2H2. So 1 gram of acetylene liberating 11.92. 1 gram of ethane. 1 gram of ethane liberating 11.32. 1 gram of ethane liberating 11.37. 1 gram of acetylene liberating 11.92. So which is better fuel? Acetylene, otherwise ethane. Acetylene is better fuel. Okay, so this acetylene is better fuel. Ethane is not better fuel because 1 gram of acetylene liberates 11.92, which is greater than this. Therefore a better gas welder is acetylene, we can say. Let us go for next sum. Calculate the heat of neutralization from the following data. So calculate heat of neutralization. Calculate heat of neutralization. Now 200 ml of 1m HCl, 200 ml of 1m HCl, 200 ml of 1m HCl is mixed with is mixed with 400 ml of 0.5 molar NaOH. 400 ml of 0.5 molar NaOH. 400 ml of 0.5 molar NaOH. The temperature rise in calorimeter. The temperature rise in calorimeter. The temperature rise in calorimeter was found to be 4.4 degrees Celsius. Was found to be 4.4 degrees Celsius. 4.4 degrees Celsius. Water equivalent of calorimeter. Water equivalent. Water equivalent of calorimeter. Water equivalent of calorimeter is 12 gram. Is 12 gram. And the specific heat is 1 calorie per ml per degree per solution. 1 calorie per ml per degree per solution. Okay. Now how to find this one we will see. Now, what are the solutions taken in the sense? One is HCl solution 200 ml. So we have taken HCl solution. How much means 200 ml we have taken. Then we have taken what in the sense? Sodium hydroxide solution. Sodium hydroxide solution, how much we have taken in the sense? 400 ml. This concentration is how much means 0.5 molar. HCl is 1 molar. What we are getting means resultant solution. Now in resultant solution, what will be there, that we will see. Now HCl reacts with the sodium hydroxide to give sodium chloride and water. Sodium chloride and water. Now 1 mole of HCl. That means here how much HCl given, we will see. This molarity and volume multiply. This molarity into volume multiply. How much you are getting? 200 ml. So 200, this 1 molar 200 ml, if you multiply 200 millimole, we will get 200 millimole of HCl. This 0.5 and 400 ml we will multiply. 0.5 molar and 400 ml of sodium hydroxide we will multiply. So what we are getting in the sense 200 millimole of sodium hydroxide we will say. Okay. So both are in same millimoles, so that both react completely. Both react completely. Nothing is remaining. HCl, sodium hydroxide, nothing is remaining. Both HCl and sodium hydroxide reacts completely, we can say. Okay. So 1 mole of HCl in the sense 1000 millimole, we can say 1000 millimole of HCl on complete neutralization releases how much heat in the sense? 57.32 kilojoule of heat. So how much heat is liberated in the sense? 57.32 kilojoule of heat is liberated. Sir, this much heat is liberated. Otherwise, this much heat is liberated. That we are taking from the concept, isn't it? We are taking from the concept. But actually what they are asking us to calculate heat of neutralization. Therefore, whether we are getting this value or not, that we have to check. Sir, so we do not know this value. This value only we have to find it, isn't it? So this value only we have to find it. Okay. So now we will take a, so this is one side. Now what we have to, what is given, that we will see. Now during neutralization heat is liberated. So heat liberated by neutralization. Heat liberated by neutralization will take. Now what is another sentence? See, calorimeter is given. In calorimeter, rise in temperature is given. In calorimeter, rise in temperature is given, was found to be 4.4 degrees Celsius. Water equivalent of calorimeter is given. Okay. Water equivalent of calorimeter is given. Okay. So now we will say that this reaction, this neutralization liberates heat. That heat is absorbed by this calorimeter and calorimeter solution. Okay. Therefore, we can say now this heat liberated by neutralization we said, and heat absorbed by calorimeter will take. Heat absorbed by calorimeter. Then which is absorbing heat in the sense? Heat absorbed by solution. Heat absorbed by solution will take. Sum of these two is equal to this. So this neutralization liberates heat. That heat is absorbed by calorimeter and solution. Okay. So neutralization, this reaction liberating heat, that is absorbed by calorimeter and solution. Okay. Calorimeter is absorbing how much? Calorimeter is absorbing ms delta t. Calorimeter absorbing heat, that is absorb, that is how much means ms delta t. Solution absorbing heat, that how much means ms delta t. Ms delta t for solution. Solution is absorbing heat, how much means ms delta t. Sir, now calorimeter. Calorimeter, mass of calorimeter into specific heat of calorimeter is called water equivalent of calorimeter. Okay, water equivalent of calorimeter. Okay, that is how much in the sense water equivalent of calorimeter given 12 gram, given that 12 gram we will take. Okay, 12 gram into delta t. Delta t is called rise in temperature. Rise in temperature is 4.4 degree. Okay, then mass of solution. Mass of solution, how much in the sense here how much what is the volume of solution means HCl is 200 ml, sodium hydroxide is 400 ml, resultant solution is 600 ml. For this solution 600 ml given. Now let us take this solution density is 1 gram per ml we will take, therefore mass is 600 gram we will say. Okay, then specific heat is given 1 calorie per ml per degree given, that one will write. Rise in temperature will substitute 4.4 will substitute rise in temperature. Okay, now let us simplify this. Let us simplify this how much we are getting in the sense this on simplification we are getting as 2692.8. What is the unit that we will see? What is the unit at that point we have to see? Okay, here specific heat unit is given 1 calorie per ml per degree. Okay, that we will take. So now they for this for solution we will take 600 ml of solution. Okay, for solution 600 ml is given. Okay, solution how much means 600 ml. Then specific heat of solution. Specific heat of solution is given here. Specific heat of solution 1 calorie per ml per degree, that we will take. So 1 calorie per ml per degree. 1 calorie per ml per degree we have taken. Then rise in temperature. Then see delta T. Delta T is called rise in temperature. Rise in temperature we will substitute 4.4 degree. 4.4 degree. What are the units get cancelled? You see now ml is getting cancelled, degree is getting cancelled. What is the remaining means calorie. Calorie is the remaining. Okay. Therefore, here we will write what is the unit means here for this ms delta T. For this ms delta T, what is the unit means calorie. For this ms delta T, calorie is the unit. Next we will see this ms delta T. This ms delta T we will see. Okay. Calorimeter. Calorimeter ms delta T we will see. Now we will take calorimeter. Calorimeter, now what is given in the sense water equivalent is given for calorimeter. Okay, water equivalent is given for calorimeter. How much is given means 12 gram we will take. Okay, water equivalent is 12 gram we have taken. Rise in temperature 4.4 degree. Okay, now here water equivalent is given. What is water equivalent, that we will see. Water equivalent. So water equivalent means mass into specific heat. Mass into specific heat. Mass unit. Mass unit if you take gram, then specific unit should be calorie per gram per degree should be there. Like this should be there. Okay. Calorie per gram per degree should be there. If mass unit given gram. Okay. Therefore, here what is the correction? What is in the question? What is the correction given? We have to check it. Okay. Sir. Now we will see this calorimeter. We'll see. For this calorimeter, this 12 I will write. Water equivalent to 12 given. Unit is what? That we will see. Unit is what? What is the unit? This gram I will cancel. So remaining what means calorie per degree, that I will write into this 4.4 degree I will write. Okay. So what is getting cancelled in the sense degree getting cancelled. Therefore 12 into 4.4 calorie. Okay. So water equivalent, that also we have said. So here what is the unit? What must be the unit here in the sense for calorimeter ms delta T unit is calorie. That means in the water equivalent of calorimeter they said 12 gram. Actually here correction is there. Okay, what is the correction? That is what is the correction means. This is the correction. Water equivalent is mass into specific heat. Mass is gram means specific heat is calorie per gram per degree. Gram cancel. Therefore calorie per degree we have to write the unit. then rise in temperature unit we have written. So we are getting calorie. Okay, sir. Therefore, this is calorie, this is calorie, therefore it is calorie. Okay, this is the total heat absorbed by calorimeter and solution. So calorimeter and solution absorbs this much amount of heat. Which is giving this much amount of heat to the calorimeter and solution? This neutralization gives. So neutralization, this neutralization liberates this much. How much a substance undergoes neutralization? 200 millimole of HCl undergoes neutralization. Okay, so 200 millimole of HCl on complete neutralization releases 2692.8 8 calories. 200 millimole of HCl. 200 millimole of HCl on complete neutralization releases 2692.8 calories. Okay, now we want enthalpy of neutralization. We want enthalpy of neutralization. Enthalpy of neutralization means 1 gram equivalent of HCl should react. 1 gram equivalent of HCl means 1 mole of HCl. 1 mole of HCl means 1000 millimole. 1000 millimole of HCl. 1000 millimole of HCl on neutralization with base releases how much amount of heat? That is this 2692.8 calories into 1000 by 200 calories. Okay, this much. So this we will simplify. How much we are getting, we will see. That is 13.464 into 1000 calories. 1000 calories. Okay, therefore this we can write it as what, in the sense 13.46 kilocalorie we can write. So this much amount of heat is liberated by 1000 millimoles of HCl. 1000 millimoles of HCl means 1 mole of HCl. 1 mole of HCl means 1 gram equivalent of HCl. 1 gram equivalent of HCl on neutralization releases how much amount of heat? That is called enthalpy of neutralization. Therefore, here enthalpy of neutralization is how much, in the sense? Enthalpy of neutralization is how much, in the sense? 13.46 kilocalories. Neutralization means heat is liberated. Liberated means you have to see negative sign we have to give, because heat is liberated. Liberated means a negative sign. Exothermic we have to say. Therefore, enthalpy of neutralization is how much? Means minus 13.46 kilocalories. If you convert this into kilojoule, we will get 57.32 kilojoule. We will get it. Let us go for a next sum. The bond dissociation energy of gaseous H2. The bond dissociation energy. The bond dissociation energy of gaseous H2, Cl2 and HCl, Cl2 and HCl are 104, 58, 104, 58 and 103 kilocalories per mole. 103 kilocalories per mole. 103 kilocalories per mole respectively. 103 kilocalories per mole respectively. Calculate the enthalpy of formation of HCl gas. Calculate the enthalpy of formation of HCl gas. Calculate the enthalpy of formation of HCl gas. Okay. Now, what is the given data? We'll see. The bond dissociation energy of gaseous H2. Okay. The bond dissociation energy of gaseous H2. For this, how to write equation, we'll see. Dissociation, in the sense which is dissociating, gaseous H2 is dissociating. Therefore, gaseous H2 will write. Gaseous H2. This on dissociation gives what? Hydrogen atoms. Hydrogen atoms in gaseous state 2 times. Okay. We have to balance. When we are balancing, we have to keep H2 as 1 mole. We have to keep H2 as 1 mole. Bond dissociation energy of H2 means the 1 mole of H2 undergoing dissociation. 1 mole of H2 undergoing dissociation. Okay. So bond dissociation energy of gases H2 means 1 mole of H2 undergoing dissociation. So 1 mole of H2 gas on dissociation gives 2 moles of hydrogen atoms in gaseous state. For this delta H, how much, in the sense 104 kilocalories given. Now, this is a endothermic process. This we can say endothermic. Why to say this is endothermic? Because hydrogen molecule contains bond. We have to break that bond. Then only we will get hydrogen atoms. Hydrogen molecule contains bond. We have to break that bond. Then only we will get hydrogen atoms. Breaking in the sense we have to supply energy. That means endothermic process. Then bond dissociation energy of Cl2. So gaseous Cl2. So Cl2 gas gives chlorine atoms in gaseous state. For this delta H is how much in the sense 58 kilocalories. 58 kilocalories. Okay. So bond dissociation energy of Cl2 means 1 mole of Cl2 gas we have to take. 1 mole of Cl2 gas we have to take. In the 1 mole of Cl2 gas, this Cl2 gas means Cl2 is molecules. We have to break the bonds. So we will get chlorine atoms, we will get chlorine atoms, we will get. For this energy, how much required means 58 kilocalories. Then HCl gas we have to take. HCl gas we have taken. 1 mole of HCl gas you take, break the bonds, you will get hydrogen atoms in gaseous state and chlorine atoms in the gaseous state you will get. For this, what is the delta H in the sense 103 kilocalories per mole. Okay, so 1 mole of HCl gas you are taking and you are breaking the bonds by supplying energy. So you are getting 1 mole of gaseous hydrogen atoms and 1 mole of gaseous chlorine atoms you are getting. For that, what is energy required for this process means 103 kilocalories of energy is required. Sir, okay. So we got three equations we got as per the given data. Then we will go for required data. We will go. What is the required data in the sense enthalpy of formation of HCl gas. So formation of HCl gas in the sense write HCl gas in the right side. Then right left side constituent elements. What is the constituent elements means hydrogen and then chlorine. Hydrogen and then chlorine. Now we have to balance this equation by keeping HCl as 1 mole. Balance this equation by keeping HCl gas as 1 mole. So we are keeping HCl gas as 1 mole. Why? Because HCl is forming. HCl is forming. Therefore, HCl gas we have to keep 1 mole. And we have to balance the rest. Therefore, we are keeping off H2 off Cl2. Like this we are keeping. Okay. Of H2 of Cl2 we have kept. Now we have balanced. For this we want delta H. For this process, we want delta H. That delta H only is called enthalpy of formation of HCl gas we are saying. For this delta H we want, that is only called enthalpy of formation of HCl gas we are saying. Okay, sir. Now how to find enthalpy of formation of HCl gas for this required equation, that we have to see. Sir, now what we have to do means let us take first equation as it is and we will multiply the first equation by what in the sense 1 by 2. First equation take and multiply the first equation by 1 by 2. Okay, so we are taking first equation and we are multiplying the first equation by 1 by 2. So we are getting like this. So for this, what is the delta H value? For this delta H value is how much in the sense 104 given, that you multiply by 1 by 2. So by 2 we have written. Okay, by 2. Then we'll take second equation. This second equation also take as it is and multiply by 1 by 2. Second equation also we are multiplying by 1 by 2. So 1 by 2 Cl2 gas gives a chlorine atom in gaseous state. For this, what is the delta H? 58 kilocalories. This also multiply by half. So 58 kilocalories by 2. Okay. Next, we want HCl gas in the right side. HCl gas is there in the equation 3 left side. So equation 3, reverse it. Reverse equation 3. So we are reversing equation 3. Therefore, hydrogen atom in gaseous state, chlorine atom in gaseous state. So HCl in gaseous state. HCl in gaseous state. For this delta H is how much in the sense minus 103 we have to say. Why? Because we are reversing. Now let us add all the equations. The required equation we are getting or not, we will see. Hydrogen atom in gaseous state getting cancelled, chlorine atom in gaseous state getting cancelled. So what we are getting in the sense of H2 gas plus of Cl2 gas gives HCl gas. HCl gas. Let us add all the delta H values. We will get required delta H. We will get, that is how much in the sense minus 22 kilocalories. Okay, this is called what in the sense enthalpy of formation of HCl gas. It is called enthalpy of formation of HCl gas. That's what asked. That's what we have found. So enthalpy of formation of HCl gas, we have got it. Let us go for next sum. So we are taking next sum. We are taking calculate the CC bond energy. Calculate the CC bond energy. Calculate the CC bond energy from the following data. From the following data. So first one is given, first subdivision, carbon solid gives carbon gas. Carbon solid gives carbon gas. Delta H is equal to how much in the sense? 170.9 kilocalories. 170.9 kilocalories. Then second subdivision, what is given in the sense of H2 gas gives hydrogen atom in gaseous state. Delta H is equal to 52.1 kilocalories. 52.1 kilocalories. Then third subdivision, heat of formation of ethane. Third subdivision, heat of formation of ethane is given. That is how much in the sense? Minus 20.3 kilocalories. Fourth subdivision, what is given means CH bond energy is given. CH bond energy. CH bond energy is how much in the sense? Minus 20.3 kilocalorie. Minus 20.3 kilocalorie. Now, so what they are asking us to find in the sense, calculate the CC bond energy they are asking. So CC bond energy we want in the sense, which is having CC bond. This ethane is having CC bond. That bond energy we have to find it. So for ethane, enthalpy of formation is given. That equation we will write first. So enthalpy of formation of ethane in the sense, we will write ethane first equation we will write. Now in this case, so enthalpy of formation of ethane we have to take. For this we will write equation. Enthalpy of formation of equation we want to write. Sorry. Ethane in the sense we will take C2H6 in gaseous state. It is forming. The constituent elements we will take, that is graphite solid plus 3 times H2 gas. 3 times H2 gas. Okay. It is called a heat of formation of ethane. Heat of formation of ethane, how much given? That we will see. Heat of formation of ethane given minus 20.3 kilocalories. Minus 20.3 kilocalories given. Heat of formation is given. Sir, okay. Next, what is the data? We'll see. Next data, what is given? Okay, what is the given data? This is what in the sense delta H given, solid into gas, this delta H given, of H2 into gaseous atoms, this delta H given, this delta H given. Sir, for these equations also, what is the meaning? CH bond energy means, what is the meaning of this means? CH we are converting into C gas and H gas. That is the meaning. C gas and H gas. That is the meaning. Okay, sir. With respect to bond energy, we will talk now. With respect to bond energy, first what we have to do means we have to convert this graphite solid. This graphite solid we have to convert into graphite gas. Graphite gas we have to convert. Gaseous atoms we have to convert. This is hydrogen molecules. Hydrogen molecules we have to convert into hydrogen atoms. Then these atoms rearranging and forming molecule. What is a molecule in the sense? Now carbon atoms will take here 2 times, then hydrogen atoms 6 times we will take like this. 6 times hydrogen atoms we have taken, then bond formation will say bond is forming like this. Okay, bond is forming like this. Therefore here bond formation means heat is liberated. Here what means endothermic. This is endothermic. This side endothermic, this side exothermic. So endothermic means this much amount of heat is absorbed. System is absorbing this much amount of heat. System is liberating this much amount of heat. That is called net value is called delta FH. Net value is called delta FH. Okay. So for this, what is the net heat involved? For this equation, what is the net amount of heat involved? Minus 20.3. Sorry. In this process, what and all takes place? Graphite solid is converting into gaseous carbon. Hydrogen molecules converting into gaseous hydrogen atoms.